Now we can see some questions on redox reactions. Now this question reads as, which of the following systems requires oxidizing agent? That is, first one is S2O3 2 minus 2 moles is in equilibrium with S4O6 2 minus. Second one, Zn 2 plus in equilibrium with zinc element. Third one, hypochlorite anion ClO minus in equilibrium with chloride anion, that is Cl minus. Fourth one, potassium chromate in equilibrium with potassium dichromate. So which requires oxidizing agent means first we have to identify the oxidizing reaction. Which is the oxidation reaction? Only oxidation reaction will require oxidizing agent. For oxidation reaction, here everywhere reactant and product composition is almost same. So we have to only compare the oxidation state of the elements and then come to a conclusion. For simpler things we can eliminate. For example, let us take the choice B. Choice B, Zn 2 plus is converted to elemental zinc. Elemental zinc, so oxidation number of elements in that state is 0. So oxidation state varies from plus 2 to 0, reduction in oxidation state. So it is a reduction reaction. So B cannot be the choice, right choice, since it is a reduction reaction. Similarly, let us come to C. In the case of C, these let us work out from A, C and D, because by visual observation we can eliminate B. First, coming to the case of A, S2O3 2 minus. Sulfur oxidation state we don't know. If we write the equation, 2 into sulfur X plus 3 into oxygen number, oxidation number is minus 2 equal to overall charge is minus 2. 2x minus 6 equal to minus 2. 2x equal to minus 2 plus 6, 2x equal to 4 or x equal to 2. So oxidation state here for sulfur it is 2. In the product side, if we write S4O6 2 minus, the same formula. So for understanding, let it be y. 4y plus 6 into minus 2 equal to charge, total charge is minus 2. So 4y minus 12 equal to minus 2 or 4y equal to 10, y equal to 2.5. So there is increase in oxidation state for sulfur from 2 to 2.5. So it is a possible oxidation reaction. However, we have to eliminate other two choices by testing the respective oxidation states. If we calculate for chlorine, so chlorine in hypochlorite, because chlorine is the common species in the reactant and product. So next question may arise, why not oxygen, etc. so forth. So whenever there is a common species, it is sufficient to compare its oxidation state. So chlorine X plus oxygen, 1 oxygen into minus 2 equal to total charge is minus 1. X minus 2 equal to minus 1 or x equal to minus 1 plus 2, x equal to plus 1 oxidation state. So chlorine oxidation state in the reactant is plus 1. In the product chloride minus 1. So there is a decrease in oxidation state. This also is an example of reduction reaction. C is also, so B is reduction reaction, C is reduction reaction. We can see a check what type of reaction in the case of, so here potassium, chromium, oxygen. Chromium has to be studied because potassium and oxygen, they have standard states only plus 1 and minus 2 respectively. So here 2 into 1 plus x plus 4 into minus 2 equal to 0. 2 plus x minus 8 equal to 0. 2 minus equal to 0. Total charge is 0. So this 2 minus 6, that is x minus 6 equal to 0 or x equal to 6. In the product side also we can check. Let us for the K2 Cr2O7. 2 into 1 plus 2 chromium atoms each with oxidation state unknown, x plus 7 into minus 2. It is a neutral compound, so its value is 0. Its value is 0. So 2 plus 2x minus 14 equal to 0. So 2x minus 12 equal to 0, x equal to 6. So chromium does not undergo oxidation state change. In this reaction, chromium is neither oxidized nor reduced. So definitely it is not oxidized. So other three reactions are not oxidation reaction. Only the choice with respect to first one, there is an increase in oxidation state from 2 to 2.5. So it is an oxidation reaction. So it requires oxidizing agent. So for the correct choice for this question is A to be identified. Now next question, it reads as in the reaction SO2 plus 2H2S giving 3S plus 2H2O, which species is getting oxidized? The question is, all the four species are given as four different choices. We have to identify. For that we have to compare with the reactant and product. So the common element present in reactant and product, they have to be considered. So SO2 is converted to sulfur and also H2S is also converted to sulfur. That is to be noted. So SO2 is converted to sulfur and H2 is also converted to sulfur. H2S to water is critical because both under oxygen sulfur, they are under the same group of elements. So it cannot be told in terms of oxidation or reduction for this combination. So this combination cannot be worked out. You have to compare only these two combinations. Here SO2 to sulfur. SO2, even if you compare the oxidation states, oxygen is 2, 2 into minus 2, minus 4, x minus 4, x equal to 4. Sulfur is in the oxidation state of 4 because x plus 2 into minus 2 equal to 0. So x minus 4 equal to 4, 0 or x equal to 4. Here sulfur is in the elemental state. So its oxidation state is 0. So it is a reduction reaction. Sulfur dioxide to sulfur conversion is reduction because sulfur is formed from both the sides. Here there is one sulfur, here there are two sulfurs, they are appearing as three sulfurs. Both are converted only to sulfur, that is to be noted. So this reaction is not oxidation, this is reduction or sulfur, or in other words commonly you can tell removal of oxygen is reduction. So sulfur dioxide is getting reduced to sulfur. These two are products, this need not be considered, only the reactants have to be considered. The other possible reactant is hydrogen sulfide. Hydrogen sulfide will split as 2H plus plus S2 minus, or we don't know means 2 into 1 plus S, we don't know, x equal to 0, 2 plus x equal to 0, x plus 2 equal to 0 or x equal to minus 2. In either fashion its state is minus 2 only. So sulfur oxidation state, here it is minus 2, sulfur oxidation state is, here it is 0. Elemental sulfur, elemental materials, their oxidation number is 0. So oxidation state rises from minus 2 to 0. There is increase in oxidation state. So sulfur, hydrogen sulfide is said to be oxidized to sulfur, whereas sulfur dioxide is said to be reduced. So one is oxidation reaction, another one is reduction reaction. Which is oxidized means automatically H2S. The choice A gets the correct choice for this question. This eliminates the other choices. This type of treatment eliminates the other choices. Now next question reads, in the chromite ore formula is FeCr2O4, that is iron chromite. This is called chromite ore. Ore is a compound of metal, so that it is a mixture of metals. Two metals occur in this ore, metallic compound which is available in the earth crust. It can be purified to get the respective metals. So it is a standard ore of chromium. Chromium is extracted in the chromite ore. The oxidation number of iron, so oxidation number of iron and chromium are respectively. The question is, in the chromite ore, the oxidation number of iron and chromium are respectively. There are 4 choices given: 3, 2, 3, 6, third choice 2, 6, fourth choice 2, 3. So A, B, C and D. So which is the correct choice? We have to identify. Once again, to repeat the question, the chromite ore of formula FeCr2O4, the oxidation numbers of iron Fe, iron and chromium Cr are respectively. So 4 choices are given. We have to see. First, it is a mixed oxide. The question itself is asked as iron and chromium are. So you got it, actually it is a mixture of these 2 compounds. That is, it is a mixture of iron oxide and chromic oxide. If you add these 2, iron, 2 chromium and 3 oxygen plus 1 oxygen, 4 oxygen. So ferric chromate or iron chromate is a mixture of iron oxide and chromic oxide. Separately now we can calculate. Iron oxide, X, oxygen minus 2 or 1 oxygen minus 2x or x equal to 2. Chromium 2y plus 3 into minus 2 equal to 0. 2y minus 6 equal to 0. Y equal to 3. Y equal to 3. So the oxidation number of iron is 2. Oxidation number of chromium is 3. So iron and chromium are given. 2, 3 is the correct choice. So this eliminates the other choices. We need not work out for all the things. This is the compound. In this way we got to work out. And if we carefully work out this choice. Otherwise, if we make a minor mistake, some of other choices may also come into picture. We have to be carefully working out the equations. This finishes the solution of this question. Now, this question is also based on the calculation of oxidation number. The question reads as oxidation states of phosphorus in 3 compounds are given. Their molecular formula are H4P2O5, H4P2O6 and H4P2O7. All are phosphorus based acids, oxyacids. They are called oxyacids. Acid is already we have studied that acid is a substance which donate protons. All of them donate protons. So they are acids. They contain enormous amount of oxygen atoms. So it is they are also called oxyacids. Oxyacids of which material? Phosphorus. So these are examples of oxyacids of phosphorus. We have to find the oxidation states. The question reads as the oxidation states of phosphorus in these oxyacids are respectively 4 choices are given. 3, 4, 5, 3, 5, 4 and 5, 3, 4, lastly 5, 4, 3. So different choices are given in this fashion. So the choices are as usual identified as A, B, C and D. It is merely the calculation with usual notations. Generally we have seen that as it is a proton donor means proton is H plus. So H plus means hydrogen's oxidation number is always plus 1. Oxygen is oxide. Generally oxides are more stable. In oxides, oxygen itself outermost has 6 electrons. So if it gets 2 electrons, it attains inert gas configuration. For this reason, O2 minus is stable. So oxidation state of oxygen is also minus 2. So these are the usual notation. Hydrogen oxidation state plus 1, oxygen oxidation state minus 2. Then we have to find, so actually the phosphorus is asked here. These are, so hydrogen and oxygen are fixed states, having fixed states. We have to with the usual notation. So we got to sum up the oxidation numbers. all are neutral molecules, so they have to be equated to 0 for the first case. In a similar manner, because there is only increase in every oxygen, there is also shortcut method, every oxygen. Otherwise they are same, H4P2, H4P2, H4P2. There is increase only in one oxygen. One oxygen means there will be oxidation state of successive. We can identify and then see. So first, for the first case, 4 plus 2x plus 5 into minus 2 equal to 0, or 4 plus 2x minus 10 equal to 0, or 2x minus 6 equal to 0, x equal to 3. X equal to 3. Similarly, for the next case, there is one increase in oxygen, whose value is minus 2. Otherwise, it is same. 4 plus 2x remains same. 4 plus 2x. 6 oxygen atoms are there. 6 into 2 minus 12 equal to 0. So 2x minus 8 equal to 0, or x equal to 4. For the last case, in a usual manner, it becomes 4 plus 2x minus 14 equal to 0. So for every increase in oxidation, one oxygen, there is increase in oxidation number of only minus 2. So 4 plus 2x minus 14, or 2x minus 10 equal to 0, or x equal to 5. So the oxidation states of phosphorus in 3 different compounds are 3, 4 and 5. So all these are to be in correct order. We have, so all these 3, 4, 5 will be repeated everywhere, but in an erratic manner it will be repeated. So we have to be careful in identifying. Here the first choice, A, 3, 4, 5 is the correct choice for this question. This finishes the analysis of the current question. Now, the next question also based on the calculation of oxidation number. This question reads as, here so far we have compared different oxidation states and written, consolidatedly written. Now, we have to find the oxidation number of one element in all the compounds and which is highest, we have to see. So the question reads as, the highest oxidation state of manganese. The highest oxidation state of manganese is present in dash. It is given 5 compounds are given, some 4 or 5 compounds, which is having highest oxidation state. Actually 4 compounds are given, so 4 choices, K2, M1, O4, M12, O3 and M1, O2. These are oxides of manganese. This is called, KMnO4 is called potassium permanganate. This is called potassium manganate. Potassium manganate. This one manganic oxide. This is manganese oxide. That's all. So they are named after the oxidation state of manganese in these elements. With the usual notation, all contain potassium, manganese and oxygen, or either only manganese and oxygen. So oxygen is stable as bivalent anion state oxide. So oxygen oxidation number is always minus 2. Potassium is alkali metal, first group metal. Its value is plus 1. First group metal, valency is plus 1. Oxidation state is also plus 1. So 1 plus manganese, it has to be compared. Plus x plus 4 into minus 2 minus 8. So x equal to 7. This is the solution 7. Here 2 plus x minus 8 equal to 0, or 2 minus 8 minus 6, x minus 6 equals 0, or x equal to 6. In the third case, 2 3s are 6, 3 2s are 6. In any fashion, you can 2x minus 6 equal to 0, or x equal to 3. Last case, x minus 2 into 2, 4. 2 oxygen atoms whose oxidation state is minus 2. So x equal to 4. So the different oxidation states are 7, 6. They are successively membered. For manganic oxide it is 3, 4. 7, 6, 3, 4. The maximum value is 7. So highest oxidation state compound is A, potassium permanganate. This eliminates other choices. So the correct choice, the actual answer for this question is the highest oxidation state of manganese is present in potassium permanganate. So this finishes the current question. So far we have discussed the questions regarding merely the calculation of oxidation number. The current question is somewhat aiming at also the balancing. We also studied salient points about the balancing of redox equation. This question reads as how many moles of iodine? How many moles of iodine are liberated when 1 mole of potassium dichromate? Potassium dichromate formula is K2Cr2O7 reacts with potassium iodide. Reacts with potassium iodide in acid medium. In acid medium. So the question, to repeat once again, how many moles of iodine are liberated when 1 mole of potassium dichromate K2Cr2O7 reacts with potassium iodide in acid medium? So it is given. So from this they have given the possible reactants and products. We have to arrive at the correct redox equation. K2Cr2O7 reacts with Ka. So there is a reaction between these two. How many moles of iodine are liberated? Means that they are asking only how many moles. So they are fixed. They have fixed that iodine is liberated from the equation. So one of the products is I2. One of the product is I2. So the reactants are K2Cr2O7 and Ki. In acid medium is also given. Acid is provided, as we have studied that acid is a proton donor. Acid is a proton donor. So from this we have to, now we are having some idea about the possible reactants and products. Now we have to get a balanced equation. So this can be easily solved by ion electron method. We have studied one method called ion balancing of redox equation by ion electron, ION. Ion is a charged particle. Ion electron method. Let us write the first only the ionic equation. Cr2O7, number of times we have studied, it is bivalent anion. Cr2O7 is a bivalent anion. Ki, all inorganic compounds are ionic compounds generally. Covalent character may increase depending upon the size later. So Ki, if it dissociates, K plus and I minus. This is also forming. So there is a reaction between reaction. You got to be careful. It is we should not come into the picture like charges will repel each other. Not like that. This is not the physical interaction. This is a chemical reaction. Iodide reacts with dichromate in acid medium. Acid is a proton donor. It gives I2. This is the possible. From this, what are the now? First step we have written the ionic equation. It is not balanced. There is no conservation of mass. Then we have to see which are reduced, which are oxidized. From this, we can write off-cell reaction. That is, off reaction is iodide conversion to iodine. Iodide conversion to iodine. If you balance, 2I minus gives I2 plus 2 electron. 2I minus giving I2 plus 2 electron. 2I minus oxidation state is minus 1. I2 oxidation state is 0. So iodide is said to be oxidized to iodine. We have identified one off reaction. So one reaction is reduction means, sorry, oxidation. So iodide is oxidized to iodine. One reaction is oxidation means other reaction is reduction. Other reaction is reduction. We have to identify. What happens to chromium? Here chromium oxidation state we have many times calculated. Anyhow, repeat. Cr2O7 2 minus, that is 2x minus 7 2s are 14 equal to minus 2. 2x equal to minus 2 plus 14, that is plus 12. X equal to 6. X equal to 6. So chromium valencies, standard valencies of chromium are 3 and 6. Chromic sulfate is Cr2SO4 thrice. So chromium generally is reduced to 6 plus. Cr6 plus is reduced to Cr3 plus. That is, here it is oxidation. It is oxidation. Iodine oxidation means loss of electrons. Iodide is oxidized to iodine, means iodide loses 2 electrons to form molecular iodine. Here Cr6 plus is reduced to Cr3 plus, or in other words it can be written as Cr6 plus plus 3 electron giving Cr3 plus. So these are the possible of reaction. One is oxidation reaction, another one is reduction reaction. So now we have identified which is the species oxidized and which is the species reduced. Dichromate is reduced to trivalent chromium, or chromium, hexavalent chromium is reduced to trivalent chromium. Iodide is oxidized to iodine. But next question arises, what happens to oxygen? So oxygen will be appearing in the form of water because H plus is there. So oxygen will be, so there is one point telling that you adjust for oxygen, hydrogen, etc. in the product side in terms of water or hydroxyl ion. Water means, oxidation means you can use water. Reduction means hydroxyl ion. Hydroxyl ion we cannot put here. A question may arise, why not hydroxyl ion? Hydroxyl ion is a base. Hydroxyl ion is a base. Here it is specifically mentioned as acid medium. So only H plus. So possible Cr2O7 2 minus plus I minus plus H plus. How many electrons we don't know. How many electrons? Giving 2 Cr, because it has to be conserved in mass. 2 Cr, we have just seen that Cr3 plus. Cr6 plus is converted to Cr3 plus plus I2 plus H2O. So acid medium means it is dissolved in water. So oxygen is converted to water, protons are converted to water, hexavalent chromium is converted to trivalent chromium, and iodide is oxidized. So or in other words, hexavalent chromium is reduced to trivalent chromium, iodide is oxidized to iodine. The reaction takes place in the presence of acid medium. Both oxidation and reduction involve transfer of electrons. These are borne in mind. Now we got to check for charges. Before that, even conservation of mass. 2 iodine atoms are there in the product side, balance 2 iodine in the reactant side. So 2 iodine I2, 2 Cr, 2 Cr. 7 oxygen atoms are in the reactant side, only one product is 7. So 7 water molecules are formed, 7 water molecules, but H plus we don't know, 7 H2 you can readjust from product and reactant side. So 7 into H2, 14 hydrogen atoms are there in the product side. The only source for reactant side is here 14 H plus. 14 H plus. So now we can cross check once again. So 2 Cr, 7 oxygen, 2 iodine, etc. Hydrogen, 14 hydrogen, everything. But charge is not yet balanced. Remember, balanced charge is in terms of to be supplied in the form of oxygen. Product charge is 2 3s are 6 plus. These are neutral. Iodine is neutral, water is neutral. Product charge is 6 plus. Reactant charge minus 2. So reactant charge also should be plus 6. So minus 2, 2I minus. Another minus 2 plus 14. How many electrons we don't know. We can solve. So minus 4 plus 14 plus 10. 10 plus x, 10 plus x equal to 6. 10 plus x or x equal to 4. 4 electrons. X equal to 4 electrons. So this finishes. Now lastly, after checking, so 2 Cr, 7 oxygen and 2 iodine, 14 hydrogen, total charge is balanced. Now it is correct. Now the balanced equation, in the product side only 1 mole of iodine is formed. Number of moles of iodine is asked. Actually the choices given are, they have given 4 choices. 1, 2, 3, 4. The correct choice is 1 mole of iodine is formed during this reaction. This explains. So the same reaction can also be carried out in alkaline medium under certain conditions. Once again, that is to be noted, not necessary with respect to dichromate, because that can be with permanganate, because it is a standard redox titration. We have studied about redox titration. For iodometric titration, they will add potassium dichromate and sulfuric acid. So dichromate is reacted with iodide in the presence of only acid medium in normal titrations, which we have balanced and got the answer. This is the method to approach this question. So the 1 mole of the answer for this question is 1 mole of iodine is formed by the reaction with 1 mole of dichromate with potassium iodide in acid medium. This finishes the current question discussion.